This is Zen. Zen has been a close friend of mine for the past 8 years. He's funny, good at games, and smart. Like machine learning smart. In fact, Zen is so good at programming that he made his own portfolio website filled with his projects and demos. This is where we find Eagle Eye. My friends and I had recently began playing a Sporkle game where the player has to press all of the numbers from 1 to 50 in order based on their random location. Everyone wanted to be the one with the fastest time. Zen ended up remaking this game on his website where we could all play and see all of our scores on the leaderboard, but for the life of me, I couldn't get up to the top 10. No matter how hard I tried, I could never keep up with the fast pace set by everyone else. In my position, some people may have continued practicing, tried to hone their skills and get the treasured first spot on the leaderboard. But there's a key detail about me I haven't told you yet. I'm also a programmer. Here's how I taught an AI model how to destroy my friends and get the top spot in Eagle Eye.
Suffer as I have.
In order to perform like a machine, we need to first think like a machine. So let's first understand the core building blocks of the game. This is going to sound so simple and you'll ask, Kushal, why are we going over this? But I promise it'll make sense. Just bear with me. The game works by making a 10x5 grid of randomly generated numbers. In this case, when we mention random, it means that the spaces are randomized, not the numbers. At least for the way that we're going to look at the problem. Each number is restricted to a specific box, and clicking the number, if correct, will let you continue on. If it's wrong, it'll display the input and the correct choice that you should have picked, but it'll prevent you from continuing. Ultimately, it's a simple game, but our machine will not see a game. Rather, a series of code that tells it how to interpret what it's seeing, which is why it's so important to start off with a solid foundation on our understanding of the game. While we can't make this exploit fully foolproof, we can figure out a way so that whatever Zen does to try and mess with my potential scoring, the algorithm can find a way around. And with that, let's move on to the next stage of the operation, reading the numbers.
That sign can't stop me because I can't read.
For this project, we'll be using everyone's favorite language, Python. Python is great because it comes with a lot of built-in tools that we can use to help expedite the process. Now, unfortunately, this is a part of the project where I do need to get technical. For the sake of our calculations, we're going to assume that these blocks are 60 pixels by 50 pixels. In order to expedite the training process, I actually made a tool where I could click on various number fonts across the web and it grabbed screenshots of those particular numbers. Despite being a laborious process, it gives us a solid groundwork for our model to train on, and this way, if Zen ever changes the font in the future, it won't impede the program. We can now train our model by throwing every single image we have at it. We can use this alongside the MNIST dataset to ensure that we get the right values. Now, after just a little bit of code, we can now identify the numbers on the screen. Now comes the next part, understanding the numbers.
Numbers, basically. What do they mean?
Now that our model has all of these numbers, we need to make it so that it understands what it's reading, and more importantly, knows what to do with the numbers. Initially, we'll have it take a screenshot of my desktop. This is where we can run some post-processing to make the picture easier to look at. First, we'll grayscale the image. Then we can crop it. Then we invert the layers. Finally, we get rid of the borders. Now we have a clear image of all of the numbers and where they're located in relation to each other. Now the program can go through each location and identify which number is at each one. It does this by evaluating similarities between the trained version of the number and the current one. Then we can add it as a key value pair into a dictionary we made. That's all the setup that this project needs, so let's get into the fun part.
We find Cusco. Oh yeah, it's all coming together.
Now that we have all of the digits in their locations, we simply search for the key, go to its location, and click that value. Then we wait the buffer time, and then go on to the next one. It seems really simple, but I'm cutting out hours of hard work and trying to figure things out. I also bound it to a hotkey so that I could trigger it at any time. And when you put it all together, it looks a little something like this.
Wrap it up.
So we've officially beaten the game. I did have a couple qualms about stealing all of the leaderboard spots, so don't worry, I only just took one, just to show that I could. Also, Zen, if you're watching, I apologize for massacring your game. I hope you will find it in you to forgive me after this. All of the resources, including Zen's webpage, I'll try and link somewhere. I don't know how many people are going to see this, but this is my first time making something like this, so I hope you all enjoyed. Hopefully my explanation of things makes sense. I am fairly new to these technologies, so sometimes I don't know what I'm doing. This was a great beginner project for me, and I honestly got a lot of experience just putting my mind to something, so I'm really grateful for that. Once again, thank you to Zen for letting me use his page to practice. I'll see you soon, bro. Anyway, that's all I had.